Hey, what's up? It's Jake from Nimbus DevOps. And now I'm going to get into object-oriented programming and code reuse. So it should be pretty clear after this class init file that I worked on last video that OOP is all about code reuse. Um, so you define a class, you create instances. Those instances use methods that are defined only in the class, and then they'll behave differently according to how the instances have been set up by the initializer. So let's talk about inheritance and composition. So let me make a file here, and we'll just call this class inheritance.py. Okay, so what the heck are we talking about? So this is just half the story. Okay, object-oriented program is way more powerful than what I'm about to show you, but we have two main design constructs to use, and that's inheritance and composition. So inheritance, I can put this in here. Inheritance means that two objects are related by means of an is a type of relationship. Okay. On the other hand, composition means that two objects are related by a has a type of relationship. Relationship. There we go. So that's the difference. It's very easy to explain with an example. So I'm just going to show you one. So let's say I have a class engine. And I'm going to define start self pass and then define stop self pass. Okay, and then I'm going to make another class called electric engine, which takes the argument engine. Okay, so it is a engine, or is an engine, right? And I could just say pass. And then I could make another class called a V8 engine and pass the argument engine. And this also is a engine. It's a type of engine, right? Pass. It's an instantiation. It's an instance of an engine. Just like we saw, a man is a human, a woman is a human. They're both humans. They are they is a. Man is a human. Woman is a human. Electric engine is a engine. V8 engine is a engine. Okay. So that's your class. This is just getting into class inheritance. So then we want to declare some car types that will use these engines. So if I make a class called car, you don't know anything about this car, right? This is a brand new car. It's got a new method. It's got an init method. Everything is just blank until now. So I say engine, CLS for class, we'll say is engine. Okay. And then what I'm going to do is I'm going to define init self and say self.engine equals self.engine underscore class, which means that this car has a engine. Does that make sense? So the car isn't an engine. The car just has an engine. All right. And I can even say define start self, and I could print starting engine 0 for car 1 vroom vroom. Okay, and I can do that, and then I can just say dot format, and then self dot engine dot underscore class underscore dot name, comma, self dot underscore class underscore dot underscore name underscore, close that. There. Got this. Is this closed? This is closed here. Did I miss anything? Print format. Got it. Got it. This doesn't need to exist. So then here, let me pull this out so it's in line with print statement and say self.engine.start. Boom. And then out of here, I can define my stop with self.engine.stop, and then that would be a car. Okay. I could also make a class called race car and pass car, because guess what? This is code reuse. This is a car. So now you can see that this race car is a car which has a engine, and I'm starting to reuse these classes, and I can create now. I don't need to define the engine, that it has an engine or what the engine things are in a car, and I could make a race car, I could make a truck, I could make a whatever I wanted to. So let's illustrate that. So I could say that the engine underscore CLS equals a V8 engine, right? And that's all I would need to say, because the car class handles everything else. So now in race car, it's just very easy to define. So then I could also say class city car is a car, right? This is a car. And I could give this an engine class of electric engine. I could even go another layer up and say a Formula One car, F1 car, is a race car. Because this is a race car and also is a car. And I can just say pass. And you'll see that the engine class is the same as the parent. So if a Formula One car, capitalize the C here, is a race car, then we know the race car has a V8 engine. So we know the Formula One car has a V8 engine. And if we go down and be like, oh, well, race car is a car, it has a V8 engine, and I go to V8 engine, and I know that V8 engine is an engine, and the engine has a start and a stop, then all of that is defined under F1 just by me saying it's a race car. It has the engine class, which is the same as the parent. The parent for Formula One car is race car. Race car has an engine class of V8, ergo, and a Formula One car has an engine class of V8. Make sense? So now what happens if I say car is car, race car is race car. City car will be city car. F1 car is an F1 car. And then cars, and I could make a list, is car, race car, city car, F1 car. And then I could even do something like for car in cars, car.start. So what will happen when I start this? What do you think will happen? for car and cars. Okay, I have a list of cars. So it's going to go iterate through this sequence. So it hits the first object in the sequence. Okay, I have car. This first element, sorry, in the sequence. I hit car. What is car? And it comes here and it says, well, car is car. So it's going to call the class car. It has an engine. It does an initialization. It has an engine class. Engine class is just engine. And it has a start. And if you call the start attribute or method, it's just going to print starting engine 0, right? So that would be my engine for car 1, whatever the car 1 is, and then vroom vroom. So let's run this and see what happens. So Python class inheritance. Oh, we got car object has no attribute class. Did you mean class? I sure did. There's a typo right there. Got it. There. Starting engine for car vroom vroom. Starting engine V8 engine for car race car vroom vroom. Starting engine electric engine for car city car vroom vroom. Starting engine V8 engine for car F1 car vroom vroom. So this code shows you both the is a and has a type of relationships between objects. So first of all, consider engine. It's the simple class that has two methods, start, stop. We then define electric engine and V8 engine, which both inherit from engine. And you can see by the fact that when we define them, we put engine within the brackets after the class name. This means that both the electric engine and the V8 engine inherit attributes and methods from the engine class, which is said to be their base class. Okay, so the engine is the base class of electric engine. The same happens with cars. Car is a base class for race car and city car. Race car is also a base class for F1 car. It's another way of saying that F1 car inherits from race car, which inherits from car. Therefore, F1 is a race car, and a race car is a car. And because of the transitive property, we can say that F1 is a car as well. City car 2 is a car. So when we define class AB, we say A is the child of B, and B is the parent of A. And the parent and base classes are basically synonyms. So are the child of and derived from. We can also say a class inherits from another class or that it extends it. And that is the inheritance mechanism. So now we go back in the code. Each class has, and you look at it, each class has an attribute engine class, which is a reference to the engine class we want to assign to each type of car. So a car has a generic engine, while the two race cars have a V8 and the city has an electric. When a car is created in the initializer method, okay, here, when the car is created, we create an instance of whatever engine class is assigned to the car and set it as the engine instance attribute. Okay, so when we create this car, if I create a race car, any car, it's initialized and self-engine is whatever the engine class is. And in here, we're passing instance attributes to define what the engine class is for each instantiation of a car. Hopefully that makes sense. It's kind of confusing. So it makes sense to have engine class shared among all class instances because it's quite likely that all instances of the same car class will have the same kind of engine. On the other hand, it wouldn't be good to have a single engine, an instance of any engine class, as a class attribute because when we would be sharing one engine among all instances, they'd all have the same engine, which is not correct. So the type of relationship between car and engine is the has a type, and the car has a engine, and that is called composition. Okay, so you got inheritance, and now we've got composition. So has a is your composition. And that reflects the fact that objects can be made of many other objects. So a car has a engine, gears, wheels, a frame, doors, seats, etc., etc. So when you design object-oriented programming code, it's important to describe objects in this way so that we can use inheritance and composition correctly so you can structure your code in the best way. So let's just verify the correctness of what we're saying in our code. So if I were to say I've got all this stuff down here, right? So instead of saying start, let's take this out. I've got my cars. So instead of doing this, let's say we're going to create a tuple, and we'll say car, and then we'll pass the string car. Okay. And then we'll make another tuple, and we'll say race car, race car. Another tuple, city car. You can see where I'm going with this. City car, city car. Close that up. And then F1 car, tuple, F1 car. Okay, so there's my list. And then what if I want to have car classes? So I could say I have the classes of car, race car, and F1 car, because those are the different classes of car that I have. So then I could say for car underscore name in cars, and then nested in that for class underscore in car underscore classes belongs equals is instance car class, and make a little message says is a if belongs else is not a, and then print our car name, our message, and our class dot underscore name. Is that, or did I miss something here? Print car name, message, class, class underscore. That's right. Underscore name. And what do you think this is going to print, right? What do you think this will print? Let's take a look here. Car is a car. Car is not a race car. Car is not a F1 car. Race car is a car. Race car is a race car. Race car is not a F1 car. City car is a car. City car is not a race car. City car is not a F1 car. F1 is a car. F1 is a race car. F1 is a F1 car. So as you can see, car is just an instance of big car, capital C-A-R, while race car is an instance of capital race car and of car by extension. An F1 car is an instance of F1 car, and both race car and car by extension. Just like banana is an instance of banana, but it's also a fruit. And it's also a food. It's the same concept. So to check whether an object is an instance of a class, you can use the isInstance function like I did on line 52. And it's recommended over like sheer type comparison. When you're like type object is class, you can just use isInstance is better. And you can also check inheritance. The same setup but different logic in the for loop. So like for example, if I just comment this out real quick, and then under this I put for class 1 in car underscore classes, for class 2 in car underscore classes is underscore subclass equals is subclass, so it's another version 1, class 1, class 2, and then say message equals, and then 0, 0, a subclass of dot format, and then maybe is if is underscore subclass else is not. It's kind of a neat trick, huh? Let's see, is not, and then just print out class1 dot underscore name, comma message, comma class2 dot underscore name. And what do you think that would print? Well, let's take a look here. Let's take a look. Car is a subclass of car. Car is not a subclass of race car. Car is not a subclass of F1 car. Race car is a subclass of car. Race car is a subclass of race car, but race car is not a subclass of F1 car. F1 car is a subclass of car and race car and F1 car. So interestingly, you'll see here that a class is a subclass of itself. You can check the output like I just said here and read through it if you want and see if that matches up with what you're thinking in your brain. And just know that that relationship, like I said, it has a is a and has a relationship where inheritance is where two objects are related by means of is a, like a race car is a car, and composition where two objects are related by a has a, like a car has a engine. A race car has a engine. A race car is a car, that kind of stuff. So, one thing to notice about convention is that class names are always written using capital words, like with a camel case, where electric engine has both a capital E and a capital E. And race car, capital R, capital C. It's the more correct way to do it, as opposed to functions and methods, which are written in snake case, which is usually like lowercase word underscore lowercase word underscore lowercase word. So when the code you want to use is a name that clashes with a Python reserved keyword or built-in function or class, the convention's to add some sort of trailing underscore to the name. And like a for loop, for example, where you're looping through class names, and I put like the class is a reserved word, right? Class. But you'll see that in my for loop here, I was like class underscore, and I just added an underscore because the the name class was reserved. So yeah, that's just a little thing I did there that I want to make sure you recognized and understood. So hopefully this makes sense, and I really enjoyed going over inheritance and composition with you. If you have any questions, let me know, and if not, then we will move on to our next session on accessing base classes.